Hello all, good morning. This is Dr. S. Subbulakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Differential Equations and Transforms, and now we are on to the topic of Laplace transform. We will continue the problem from the previous video. What is the problem? We are going to solve the second order linear differential equation, which is y double dash plus 5y dash plus 6y is equal to 2, and we are given with the initial conditions like this. So what we have done, we have taken the Laplace on both the sides. We have split up the terms like this. Since we have three terms, we have three Laplaces here, which is equal to L of 2. And in the next step, we have applied the result number 2 and result number 1 in the place of y double dash and y dash, so that the equation becomes s squared into so and so. And in the next step, we have applied the initial conditions given here in the question. So it is found to be 0, and therefore the values will vanish here. So the remaining terms are s square into L of y plus 5s into L of y plus 6 into L of y, which is equal to 2 into L of y. What we have done here, L of 1 is 1 by s, and we have taken up L of y outside, so that the values here are s square plus 5s plus 6, which is equal to 2 by s. So in bringing this factorizing term to the other side, the quadratic equation to the other side, you will have L of y is equal to 2 divided by s into s square plus 5s plus 6, and L of y is equal to 2 divided by, on factorizing it, you will have s plus 2 into s plus 3. Now y of t is equal to L inverse of 2 divided by s into s plus 2 into s plus 3. What is the next step? Here we have our y of t to be L inverse of 2 divided by s into s plus 2 into s plus 3. So now we are going to use partial fractions method to find or to get the separated value of this bracketed term. So we are going to consider 2 by s into s plus 2 into s plus 3. So what do we have here? 2 divided by s into s plus 2 into s plus 3, which can be replaced using partial fractions, since we have only linear terms of the denominator, so that we will be replacing it like a by s, a is a constant, plus b by s plus 2, b is also a constant, plus c divided by s plus 3, c is also a constant for 3 of the terms on the denominator. So on taking LCM, on the LHS you have 2, which is equal to a into, leaving this denominator, these two have been put up here, plus b into, leaving this denominator, these two have been put up here, and plus c into, leaving this denominator, these two have been put up here. So what is your actual term here? On the denominator term will vanish, since it will get cancelled on the other sides, so that this is 2 is equal to a into s plus 2 into s plus 3 plus b into s plus 3 plus c into s plus 2. Now we have got an equation which gets is yet to find with the constants here. So now you substitute s is equal to 0, this term and this term will get vanished. So since it is product here, if s is equal to 0, this will vanish. Therefore 2 is equal to a into 0 plus 2 is 2, 0 plus 3 is 3. 2 into 3 is 6. On either side it will get cancelled. Therefore the value of a here is 1 by 3. In a similar way, we are going to find the value of b and c. Now, in the next step, we are substituting s is equal to minus 2 on the value there. So 2 is equal to b into minus 2 into minus 2 plus 3, where your a and c value will get vanished. Therefore 2 is equal to minus 2 into b. Therefore what you will get? b as a value of minus 1. In a similar way, you are substituting s is equal to minus 3, so that your a and b term will vanish and the c term will remain. Minus 3 into minus 3 plus 2. The value here is 3c, which is equal to 2. Therefore, c is equal to 2 by 3. So this is how we implement partial fractions method to find the values of the constants to separate the Laplace functions there. So now here L of y is equal to a by s. What is your a? A is 1 by 3, so 1 by 3s minus 1 into b by s plus 2 plus c into c divided by s plus 3. So 2 by 3 into s plus 3. This is a by s plus b by s plus 2 plus c by s plus 3. So we have replaced with the values of a, b and c. Now what is y of t? Y of t is equal to L inverse of all these terms. So L inverse of 1 by 3 is minus L inverse of 1 by S plus 2 plus L inverse of 2 by 3 into S plus 3. This 2 by 3 is constant, so I have taken it outside. Therefore, L inverse of 1 by S plus 3. Therefore, y of t is equal to 1 by 3. L inverse of 1 by S is 1. Therefore, it is 1 by 3 minus e power minus 2t s1. L inverse of 1 by S plus a is e power minus at plus 2 by 3 into L inverse of 1 by S plus a is e power minus at, which is 3t here. So, this is our solution for the given second order differential equation. This is how we find or we apply Laplace transforms or inverse Laplace transforms to find the solution of the differential equations. Thank you.